Download this code from codegive.com, link in the description below. Demystifying EXC_bad_access in MTLDebugTexture, a comprehensive guide. Encountering an EXC_bad_access error with MTLDebugTexture while developing metal applications can be frustrating. This error, often indicating a memory access violation, can stem from various issues related to how you're managing your textures. This comprehensive guide will delve into the common causes of EXC_bad_access with MTLDebugTexture, provide code examples illustrating potential pitfalls, and offer strategies for debugging and resolving these issues. Understanding EXC_bad_access. EXC_bad_access, or kern_invalid_address, signifies that your program attempted to read from or write to a memory location it doesn't have the right to access. This is a fundamental memory safety error. In the context of MTLDebugTexture, it usually means that you're trying to interact with a texture object that is no longer valid, hasn't been properly initialized, or is being accessed improperly. The MTLDebugTexture provides additional debugging information, making it easier to track down these memory access problems. Common causes of EXC_bad_access with MTLDebugTexture. 1. Texture deal location asterisk. Asterisk problem asterisk the most common culprit. You might be trying to use a MTL texture after it has been deallocated. This often happens when the texture is a local variable that goes out of scope or when you manually release the texture but then try to use it later. Asterisk code example, Swift. Asterisk solution asterisk store the MTL texture in a property of a class that persists throughout the texture's lifetime. Ensure the owner of the texture has a strong reference to it. 2. Incorrect texture usage flags asterisk. Asterisk problem asterisk MTL textures have specific usage flags, example .shader read, .render target, .shader write. If you try to use a texture in a way that's not allowed by its usage flags, you might trigger an EXC_bad_access. For example, attempting to read from a texture created only for render target usage. Asterisk code example, Swift. Asterisk solution asterisk carefully review the texture's intended use and set the appropriate usage flags when creating the MTL texture descriptor. Use a combination of flags if the texture needs to be used in multiple ways, example .shader read .render target. 3. Uninitialized textures asterisk. Asterisk problem asterisk you might be trying to read from or write to a MTL texture before it has been properly initialized with data. This can happen if you create the texture but never load any initial data into it using replace region, or if you pass the texture to a shader without writing anything to it during a render pass. Asterisk code example, Swift. Asterisk solution asterisk before using the texture, load initial data into it using replace region or by rendering into it. 4. Incorrect buffer sizes / offsets asterisk. Asterisk problem asterisk when writing data into a texture using replace region, you might provide an incorrect buffer size, row bytes, or region that exceeds the texture's boundaries. This can also happen when using get bytes to read data. Asterisk code example, Swift. Asterisk solution asterisk double check the following. Asterisk bytes per row in replace region should be a multiple of the pixel size, example 448 unorm, and should be large enough to hold a complete row of pixels. Asterisk the region you're using in replace region and get bytes must fit entirely within the texture's dimensions. Asterisk the size of the pixel data buffer you're passing must be large enough to hold all the data being written or read. 5. Thread safety issues asterisk. Asterisk problem asterisk metal objects, including MTL texture, are not thread safe. Accessing the same MTL texture from multiple threads concurrently without proper synchronization can lead to data corruption and EXC_bad_ access. Asterisk code example, illustrative, difficult to reproduce reliably. Asterisk solution asterisk use appropriate synchronization mechanisms such as asterisk serial dispatch queues asterisk execute all texture related operations on a single serial queue. Asterisk locks, example NS lock protect critical sections of code that access the texture with a lock. However, be very cautious about lock contention and its impact on performance. Asterisk command buffer dependencies asterisk the preferred approach in Metal is to structure your command buffers to explicitly define dependencies. One command buffer can write to a texture, and a subsequent command buffer can read from it after the first command buffer has completed. 6 Metal API validation issues asterisk problem asterisk sometimes, even if your code seems correct, the Metal API might be encountering an internal error due to incorrect configuration, driver bugs, or hardware limitations. These can manifest as EXC_bad_ errors, even if the actual memory access appears valid from your code's perspective. Asterisk solution asterisk ensure you have the latest Xcode and device OS versions. Enable Metal API validation, see debugging section below, to catch API misuse earlier. Simplify your code to isolate the problem. If you suspect a driver bug, try testing on different devices or OS versions. 7 Memory corruption asterisk problem asterisk although less common, general memory corruption elsewhere in your application can eventually lead to an EXC_bad_ access when interacting with a MTL texture. This is because memory corruption can overwrite important metadata associated with the texture object. Asterisk solution asterisk use memory debugging tools, see below, to track down the source of memory corruption. 8 MIP issues asterisk problem asterisk if you're working with MIP textures, you might encounter problems if you try to access a MIP level that doesn't exist or that hasn't been initialized. Asterisk solution asterisk ensure that the MIP levels you're accessing are within the valid range, 0 to texture.mipmap level count, 1. Initialize all relevant MIP levels before using them. Debugging EXC_bad_ access with MTLDebugTexture. Apple provides powerful tools to help diagnose EXC_bad_ access errors in Metal. 1 Metal API validation asterisk purpose asterisk this is your first line of defense. It checks for common errors in your Metal code, such as incorrect usage of the API, resource conflicts, and memory access violations. It can catch errors before they lead to crashes. Asterisk how to enable asterisk scheme editor asterisk go to product-scheme-edit scheme. Asterisk select the run scheme in the left pane. Asterisk select the diagnostics tab. Asterisk check the Metal API validation checkbox. Asterisk environment variable asterisk set the environment variable metal_device_wrapper_type to 1 in your run scheme. This has the same effect as the checkbox. Asterisk benefits asterisk API validation will produce detailed error messages in the console, pointing you to the line of code where the error is occurring and providing context about the nature of the problem. 2 Metal system trace asterisk purpose asterisk a powerful performance analysis and debugging tool that allows you to capture a detailed timeline of Metal API calls, GPU activity, and CPU utilization. This can help you identify bottlenecks, resource contention, and unexpected behavior. Asterisk how to use asterisk Xcode instrument asterisk run your app in Xcode. Asterisk go to Xcode-open developer tool-instruments. Asterisk choose the metal system trace template. Asterisk start recording. Asterisk interact with your app. Asterisk stop recording and analyze the trace. Asterisk benefits. Asterisk the metal system trace visualizes the execution of your metal code, allowing you to see exactly when textures are created, accessed, and released. It can also reveal issues like excessive memory allocations or inefficient resource management. 3. Address sanitizer, ASAN. Asterisk purpose. Asterisk ASAN is a memory error detector that can catch various types of memory corruption, including buffer overflows, use after free, and double free errors. Asterisk how to enable. Asterisk scheme editor. Asterisk go to product-scheme-edit scheme. Asterisk select the run scheme in the left pane. Asterisk select the diagnostics tab. Asterisk check the address sanitizer checkbox. Asterisk benefits. Asterisk ASAN can help you identify memory corruption issues that might be indirectly causing EXC_bad_access errors when interacting with metal textures. 4. Guard malloc. Asterisk purpose. Asterisk a memory allocation debugging tool that helps detect memory corruption and overruns by placing guard zones around allocated memory blocks. This can help you identify errors that are corrupting your texture memory. Asterisk how to enable, Mac OS. Asterisk set the environment variable malloc guard edges to 1 in your run scheme. Asterisk benefits. Asterisk guard malloc can help pinpoint the source of memory corruption that might be affecting your textures. 5. Debugging strategies. Asterisk isolate the problem. Asterisk simplify your code as much as possible to isolate the specific line or section of code that's causing the crash. Comment out code, remove features, and reduce the complexity of your shaders to narrow down the issue. Asterisk check for premature deal location. Asterisk carefully review the lifetime of your MTLTexture objects. Make sure you're not accidentally releasing them too early. Use MTLResource.label to give your textures meaningful names, which makes it easier to track them in the metal system trace. Asterisk inspect texture descriptors. Asterisk double check the parameters of your MTL texture descriptor. Make sure the width, height, pixel format, and usage flags are correct for the intended use of the texture. Asterisk use breakpoints and the debugger. Asterisk set breakpoints at the points where you create, access, and release your textures. Use the debugger to inspect the texture's properties, its memory contents, and the values of variables involved in memory access operations. Code example, debugging deal location with labels and instruments. This example demonstrates how to use MTLResource.label to track a texture in instruments and identify premature deal location. Steps. 1. Run with instruments, metal system trace. Run your app with the metal system trace instrument. 2. Filter for texture. In instruments, filter the timeline for my important texture, using the label you set. 3. Analyze the timeline. You'll see when the texture is created and, crucially, when it disappears from memory, when self.myTexture=nil is executed. 4. Confirm deal location. The crash in render will occur after the texture disappears from the timeline, confirming that you're trying to use a deallocated texture. Key takeaways. EXC_bad_access with MTLDebugTexture is usually a memory management problem. Thoroughly check the lifetime of your textures. Use Metal API validation to catch errors early. Employ Metal System Trace to visualize texture usage and identify deal location issues. Consider thread safety if you're accessing textures from multiple threads. Use memory debugging tools, ASAN, guard malloc, To find memory corruption. Use labels to make debugging easier. By following these guidelines and utilizing the powerful debugging tools available, you can effectively diagnose and resolve EXC_bad_access errors in your Metal applications and ensure robust and reliable texture management. Good luck.